Hi, my name's Steve McKenzie. I'm with Oilfield Recovery Services of Texas, and we're here today to give you a demonstration of our 5-gallon per minute produced water treatment system. We're taking produced water out of Gonzales County, Texas. This water is probably about 145,000 TDS, and we're going to process it through our system. The first step is a 500 micron filter where we're taking the large particles out. Then we go through a 200 micron filtration system to reduce the size of the particles. Then we go into our level master. The level master is designed to be an automated separations tank. Once we set this on your site, we set it to the API of the oil in the region, and then you never have to touch it again. It continually feeds all of the water in. It takes all of the oil and runs it through an oil weir. Takes about 99.9% of the oil out of the first cut. It also separates emulsion or frac gels, and because it's a cone bottom tank, some of the settling of the solids down there, of course the gases go out the top, and the oil is the most precious, captured directly in a dewatered fashion. So if you would, I'd like for you to look over into the level master. You will get an idea of the weir structure and how the system operates based on physics and the given specific gravity of each of the different elements. So we follow the water coming out of the level master. This water will go into our bulk storage container. This water at this point is about 10,000 part per million FOG, free oils and greases, and has a high particulate of the TSS suspended solids. You'll see that the water's dirty, but far cleaner at this point and free of most of the oil than it was at the beginning. So from the bulk oil storage container, our next step is the de-oiling hydrocyclone. This de-oiling hydrocyclone is a device that takes the water in tangentially, running about 2,600 RPM. 96% of the flow goes out as heavy water, and then the 4% that is going out the reverse direction is taking all of the emulsion and the oil and the particulate through the back channel of a typical hydrocyclone action. We will then take the 96% of the water that comes out of this, and it's probably at about 150 part per million of FOGs at this point. So the de-oiling hydrocyclone has the effect of dropping that 10,000 part per million oil down to 150 part per million of free oils and greases. Most de-oiling hydrocyclones come in at a very high PSI. We, as you can see here, have schedule 40 PVC because we're coming in at about 60 PSI. We're going out at about 30 PSI. Very low pressure and therefore very economical to run these pumps. The last thing that is important about this particular system is we use progressive cavity pumps in order to prevent the shearing of the molecular structure of the water so that the droplets will continue to be as large and coagulated as possible. We continue on to the media filter. This is a self-cleaning media filter, and we're able to take the particulate down to everything larger than 10 micron in size is taken out, and we're able to get the water in clear of oils or free oils and greases down to 10 ppm coming out of the bottom of this filter. So this filter is special because it has the ability to be self-cleaning. It runs a backflush cycle on less than 5% of the produced water that it's using. It does not need anything from the external sources in the way of backflush water, and all of the residual solids that are cleaned out of each one of these systems goes into the bulk storage of solids and will later be dealt with. After we've cleaned the water, the brine to a point that it is clarified brine, free of all suspended solids larger than 10 micron in size and free of all oil and grease above 10 part per million, we have the option of going through a heavy metals precipitation system. And in this case, I have a dissolved air filtration where we would do the chemical dousing and flocculate the heavy metals out. So at this point, we have clarified brine. We have taken the metals out, and we have a choice to either settle that as a revenue stream, or if the TDS is low enough, we can go through the reverse osmosis and cut it down to a % of fresh RO water and concentrated brine. That completes our process of filtration. The last thing that we do is we take all of the solids and we run them through a filter press configuration. So we reduce the suspended solids and clays and the like down to a dripless cake form, and all of the water is taken back to the beginning of the system and reutilized. For us at Oilfield Recovery Services of Texas, this is what it's all about. This is the final product, clarified brine. It could also be clarified reverse osmosis water. So we're trying to accomplish the reuse for fracking of clarified brine, or the potential ag use for the reverse osmosis water, so that the waters that the industry is bringing up, it is able to reuse its own water.